let's look at another example here where we want to find the real zeros of a polynomial, and this is our example we're going to deal with. So the first thing I want to identify are what is the degree of my polynomial. Since this is a fourth degree polynomial, I know that I have at most 4 roots. At most 4 roots. And from those roots, we are now going to make potential zeros out of our p and our q term. So remember, p comes from the constant at the end of the equation, or the function. So I'm looking at all the factors of 8. That's a plus or minus 1, 2, 4, and an 8. Then I need to identify the q term. Here I have a coefficient. The q term comes from the coefficient of my leading term. So q would be plus or minus 1. Now the ratio of p divided by q are where we get our potential zeros, and you can see from this that if I were to divide all my p terms by my q term, I just simply get back all my p terms. So let's go and let's test my possible roots in the calculator. So here I have entered on the y equals the polynomial that we're talking about, and I'm going to go use the table function to find a list of possible, or the first possible root. So I'm going to put in 1, and I get back a 6. So I know that that is not a root because I need my y value to be equal to 0. So let's try -1 this time. So -1, and there I get a root. So right away I've determined that when x is equal to -1, I have a root. Now I'm going to just off to the side write this in its factored form. So I know I have a root at x is equal to -1, and in its factored form it looks like this. So let's use our synthetic division with this root to reduce this polynomial by 1 factor. So when I use synthetic division, remember, it reduces this polynomial by a factor of 1, giving me an x cubed function. So we have -1, put our little flipped over L, and let's use the coefficients here. I have a 1, -1, -6, 4, and an 8. We'll draw a line and leave a little room. Bring the 1 down and we multiply and add. So -1 times 1 is a -1, add straight down, -2. So -1 times a -2 is a +2, add straight down. So now let's multiply and add, multiply and add. Remember that you want to get a 0 down here in this last slot. That tells you that you did the synthetic division correctly. So if I have this polynomial now right here, when we do synthetic division, we reduced my original function by a degree of 1. That gives me a polynomial here, which is a 3rd degree polynomial, and I still don't know how to factor that. I know how to factor quadratics, so I need to reduce this by 1 more power. We do that by coming up here to this potential set of lists. And if these are potential roots for my original polynomial, then they will also be potential roots for this polynomial. So we're going to go back and we're going to use the table function again and find one more root on my original function, which is in the calculator. So let's plug in, I don't know, let's do +2. And there you go. +2 gives me a 0, so I know it is a root also. So I'm going to make a list over here. I'm going to add that over here. So I know that when x is equal to +2, then I have another root. So I'm going to use that +2 here. And these numbers now, and reduce this polynomial using my other root that I have determined, because again, if this is a root to the original polynomial, it will also be a root to my synthetic, my newly found polynomial. So let's bring these numbers down. 1, -2, -4, and 8. Let me make that a little clearer. -4 and 8. Okay, bring this down. We will multiply and add. Multiply and add. multiply and add, and I get a 0, so I know that I can stop. Now we reduced this guy by one more factor. That means that I am looking at some sort of polynomial that is a second degree polynomial. Whoops. It's a second degree polynomial, and I know how to factor that. Well, let me get back to the notes we were just looking at in just a second. Here it is. We know how to factor second degree polynomials by either trial and error or the quadratic formula. So this right here looks like, let's kind of summarize what we have found so far. We have, first of all, we found one of the roots. The original root was an x plus 1. The second root we found is x minus 2, and that leaves us with x squared minus 4, because this right here, when I write it back in its polynomial form, looks like x squared minus 4. So how do I factor x squared minus 4? This will break up into x plus 2 and x minus 2, because this is the difference of two squares. So at this point, one more time, we write x plus 1, x minus 2, x plus 2, and another x minus 2. So I have a repeated root occurring here, don't I? I have two of those roots that are occurring there. So we can simplify this even further by writing it as x plus 1, x minus 2 quantity squared, because I have two of them, and x plus 2. So these right here are the real roots of my polynomial that I found, or that's my polynomial function in its factored form, and I could then set each of these roots equal to 0 and solve for each one, giving me x plus 1 equals 0, x minus 2 equals 0, x plus 2 equals 0, or in other words, negative 1, positive 2, and negative 2. So not only did we find, again, not only did we find the polynomial function in its factored form, but we also found the roots to this function as well. One thing I do want to point out to you, so in this video, I went through, first time I found one root at negative 1, the second time I found a root at positive 2. In the lecture notes that are completed, that are hanging up there, notice what I did in this one. This time I found a root at negative 1, and I happened to test out a negative 2, which is also a root. So when I did my synthetic division, it starts to look a little different at this point right here. I have one root at positive 1, I have a root here at x plus 1, a root here at x plus 2, according to what I just showed you a second ago, and when I do synthetic division, I get a quadratic that looks like this. When you factor that guy, I end up with the double root or repeated root here at x minus 2, which is this function here. This function here is exactly the way I worked, is exactly the same as the one that I just worked for you on this video. Again, there's my repeated root of x plus 2 and an x plus 1. And because these are all the roots, it really didn't matter in which order I used synthetic division, because it's going to give me ultimately the same polynomial. So one last example I want to show you here. For this one, I encourage you to practice this one on your own and then check the completed notes to see that you have the same answer as what I've gotten.